자, 성함 한번 부르겠습니다. 자, 오늘은 그러면 여기 게시판 가시면은 보실 수 있어. 이게 아니네요. 죄송해요. 과제였나요? 아, 잠깐만요. 어디였지? 여기 있네요. 렉처 매티리얼 가면은 렉처 매티리얼 5번에 보면은 이 구글 드라이브를 들어갈 수 있습니다. Please go to the bulletin board. You can see the lecture material of lecture 5, and then you can download this material. So download to your local directory and unzip it, and you should be able to see a folder named called Swirl Project.
이거 PC가 업데이트 중이라 가지고.
끝났습니다. 오늘 어렵지 않아요. 엄청 쉽습니다. 엄청 쉽습니다.
저도
예, 괜찮습니다. 어렵지 않아요. 금방 해요. 오늘. 오래 걸리네. 오래 걸리지.
선생님 어디?
여기 보시면은 이렇게 돼 있습니다.
지원이 어때? 나 오빠가 진짜 웃겨. 내가 걸어가서 보자.
If you have finished downloading, go to this folder, and if you double click the Workbench project file, then you should be able to see something like this. Bum-bum. And so what we're gonna do today is create a mesh block below the mesh block right here, and then you're gonna follow the steps along the presentation file, and then of course you're gonna create another fluent and result block as well. Oh wait, I should be able to create this result block, yes. And you're gonna bifurcate this geometry block into the mesh block and follow along the presentation file. So on the material it says there was no predefined block, but what you're gonna do is you're gonna have the guideline here. So if you don't understand how things were done, you can double click this and see how it was done previously. So what we're gonna do today is we're gonna do steady state simulation of swirl tube. The reason we're working on swirl tube is in our lab we also do nuclear fusion related topic research. So in nuclear fusion reactor, there's a fusion diverter, and there's a plasma phasing component which is exposed to 20 megawatt per square meter of high heat flux system. So what we do is we develop cooling channels that can tolerate that high amount of heat flux, and we do experiments, of course, with a similar heat transfer condition, but also we do similar numerical study related to it. So this is exactly what's given today. So the reason we're doing this steady state simulation is, wait, let me see, give me a second. Yep. As you can see, this is exactly the figure that was published in a paper, and we would measure the pressure drop and heat transfer coefficient locally and globally at the same time and draw the boiling curve according to the temperature and the heat flux that the channel is tolerating. So because we're going to heat up the system from low heat flux to high heat flux, there's a single phase regime and then there's a two-phase regime starting from partial nuclear boiling. So as you can see, what we're doing today is unfortunately a single phase steady state simulation. So here, what you can see is we're basically here, not here, right? Because if we implement two-phase models, it's going to take more computational resources. So we would not finish it in time. But because it's a steady state and requires not so much number of mesh statistics, so we can finish it in time and then we can see the results. So again, what we're doing in the course is highly related to what I do or what my colleagues did in the past. For example, maybe you might be disappointed here, but for one of the on-shape tutorials, the pool boiling one is one of the figures I put in my paper. So it was literally here. So when I made this, I was thinking I should probably add this in the lecture material because I'm more familiar with the structure itself. So it's the same for today's material. We have sort of topics that are of no use basically, that are quite detached from what we actually do in the lab. But today I want to introduce you to the actual process or the research topic that we do in the lab. So this is one of the easier ones. Of course, in our lab, when we actually work on these topics, we make sure the mesh independence is achieved. So we would have I don't know, like tens of millions of mesh statistics for the geometry and the simulation. But here we have really a small amount of cells, number of cells. So we're gonna work on this. So as you double click the workbench project, you will see these 4 blocks. But we wanted to just go through how these blocks are made. So we're not going to copy them, but we're going to create a new mesh block, new geometry block, new fluent solver block, and then result block. So we're going to drag and drop and then connect them, and then we're going to work on, for example, double click the geometry, and then try to see if we can follow along. And unlike our first time, I would say we're quite familiar with the tool at this point. So you can pretty much see, sort of carelessly telling you to designate the name selection parts, but I hope you can do it. And if you don't understand how it's done, or if you want to see what steps you might have missed, you can double click the project file, and then you can compare them. So please start, and then if you have questions, please ask me. Oh, also we're gonna have gravity as well. What was it? When you do the two-phase simulation, we're gonna include the gravity, because without gravity, the bubbles won't arc yet. So keep that in mind. And let's make a table. Once you pinpoint the pressure at both inlet and outlet, you can see the pressure drop between these 2 points. Of course, it's between 2 surfaces because it's the average value. And then What we wanted to verify, which is the reason we don't have to do this if you don't want to, but what we wanted to verify was to see if this simulation value actually corresponds to either the correlation or through the experiment. So the pressure drop here is 2200 Pascal, which is very similar to the result derived by correlation, and also it's within the range of error for experimental data as well. So you might wonder if the pressure drop from the simulation is 2200, and then if it's 2600 from the experiment, the error seems very large. But in our domain of engineering, we usually tolerate this much of error. 20%, probably less than 20%. It looks like 18 per se, so it's not as large. So yeah. So anyways, when you run a simulation, always make sure you validate with either previous known or pre-existing correlations or through experimental results. So that's why what was it? If you write a paper, there's always the methodology section, but also in the next section, you always include the validation section as well. Also, small comments about the library you're using. I highly recommend using CoolProp because usually the tool that we use for material thermal-physical properties of fluid is NIST RefProp, right? This is the tool that we usually use, but we also have something called CoolProp, which is very well validated and it's free, and you can easily sort of couple it with other Python libraries. So I just want to introduce this to you. And so you don't really have to do all the Anaconda installation because you will learn Python in the later part of the lecture series. But at least you can see thermal-physical properties through CoolProp, and this would give you similar results through the correlation. 혹시 차 안 나오시는 분 계십니까? 보셨습니까 이거? 어디 계세요 지금?
라이센스.
그거 이게 말이 안 되는 게 제 생각했을 때는 플로트를 킬 때 그 라이센스 창이 뜨잖아요. 그거를 다 예스를 해주시면은 문제가 없어야 되는데, 왜냐면 이게 엔시스 제품군이 그 라이센스 공유하는 거거든요. 그래서 메시는 켜지는데 플런트 안 켜지는 게 사실 저도 이해가 잘 안 돼가지고.
아 그래요?
네.
깜빡거리는 차고 친다.
네. 아 네.
다 되셨습니까?
아주 예쁘게.
아, 잘 되었어요. 그 차업도 찍어보셨어요 혹시? 테이블 가보셨어요? 이거 찍어보셨습니까?
네네.
일레 아울렛
아울렛까지 했습니다.
했습니까? 좋습니다. 그럼 이제 이런 시스템 차업이 있구나 이런 걸 알 수 있고, 잘 되십니까?
그 이게 메테리얼 전체가 플루이드인 거고
예.
그 가운데 있는 이렇게 돌아가는 애가
솔리드.
솔리드.
예.
아,
근데 원래 이제 열전자 같은 게 커플링이 돼 있으면은 그게 막 전도도나 이런 게 있는데 지금은 그냥 바운더리 취급된 거예요 사실. 그래서 이게 조금 애매할 수 있는데 보면은 그러니까 사실 이게 동그란 게 있으면 가운데 이게 뭐 들어가는 게 있는 거잖아요. 근데 지금 여기서 시뮬레이션 하고 있는 거는 얘 바깥이랑 이거랑 하나인 거예요 그냥. 그래서 애초에 플루이드 영역이 이 채워진 영역을 빼고 나머지 영역밖에 없는 거여가지고 그렇고 만약에 여기서 시뮬레이션을 좀 더 예쁘게 하고 싶다 뭐 왜냐면 그 안에 있는 컨덕션이랑 이런 거 고려를 해야 되니까 그럼 이제 따로따로 설정을 하게 됩니다.
바운더리 컨디션이랑 뭐 이런 거.
예 맞아요. 그래서 뭐 이제 이런 형상을 바꾸면 사실 차압도 달라지고 열전달도 달라지거든요. 근데 지금 저희는 여기다 열전달을 넣진 않았고 그냥 싱글 페이스 다이너믹만 보는 그런 상황이어가지고 그렇게 계산을 하게 됐습니다. 그리고 메시 수도 엄청 작아요. 엄청 빨리 끝났어도 놀라셨겠지만 이제 뭐 사실 메시 수를 바꿔보면은 또 계산도 많이 달라지고 이래가지고 그렇습니다. 그래서 뭐 나중에 유체 역학 같은 거 좀 하실 일이 생기시면은 뭐 이렇게 일레다 원래 잡아가지고 항상 그 뭐야 저거 하시면 돼요. 라이센스가 뒤졌다. 그래서 보시면은 메시가 이런 모양인데 만약에 여기서 메시 페이스 사이징을 좀 더 줄여봐도 뭐 줄이면은 했을 때 혹시 못하신 분 아직? 차압이요? 아 왜 그러지? 진짜로?
근데 조금 알 것 같아요.
뭐가 원인이었던 것 같으세요?
처음에 플로트 이렇게 넣을 때
네.
숫자 1 표시되는 거 있잖아요. 이것저것 찾을 때
네.
그거를 제가 4를 이렇게
아 그래요?
그거 말고 차이도
그래요? 근데 원래 4로 입력하는 거 아닌가? 잘 모르겠네요.
한 번만
예. Again, to give you some head up to for the individual assignment and team work, you still have 60 days to do it. Again, the team leader will be evaluated on the basis of how well organized the structures are. Otherwise, other team members will be evaluated based on the geometry that they are providing. So, also, when you go to Onshape, you can share your material with others. So, please share it with your teammate so that your teammate can assess it. And give me a sec. And if you share it with me eventually, then I get to see all the relevant features and then what kind of features you used in the project, and then sort of evaluate it in a fair terms. So I can also see what documents are shared with me. So this is created by someone else, but this is shared with me. So eventually I can copy this to my local directory and then assess it. So what you will eventually have to do is to compress all the material and then compress into one zip file. And for the team leader, you will have to share the link to my email so I can see it. And then when you submit it, please let me know so I don't miss it. I think one of the team leaders is missing, but please let her know as well. That eventually I have to check how you made it, because otherwise you might just copy with each other, then I wouldn't know if the STL file was actually generated from you or not. So for the tutorials, I don't really care much because I assume everyone followed it through the lecture hours, but for the team project, I hope you do it with honesty and integrity. So that's one thing I expect, and it shouldn't be that much of difficulty. And so we've gone through the entire lecture again. So from the beginning of this month, we've run all the way to this point, and this Thursday will be we won't have any class on this Thursday, and probably these are our vacation national holidays Chuseok, so hope you enjoy it. On 14th, probably we'll continue with a new lecture, so that's the plan so far. So before I bring this lecture series to an end, I would give you some encouraging comments. Hopefully, what was it? You've learned, at least you can learn new things, right? So, what was it? Even though I'm a lecturer and I'm in 7th year of my PhD, I'm no different than you, any of you. We're basically the same, and then we're in the same university, same labs, and the same floor, etc. So, fundamentally, I'm not an authoritative figure, so I don't really make arguments based on authority or credentials. So, even though I'm in more of a senior position, I don't really go to my juniors and say, "Hey, like, listen to me, like, shut the hell up." Like, you have to listen because I have more experiences and I have more authority on this topic. So, outside of the lecture room, please, if you have any opportunity, please say hi to me. That'll be very, very nice. And I think also I've been teaching this course since 2022, and the first time I was offered to teach this course, I was delighted because one of the things I thought back then was that in my PhD, one of the things that are often conflated is that the knowledge that we have in our domain and the ability to implement certain methodologies are often conflated. So, for example, when it comes to using AI, it knows a lot about our domain, and probably we use it all the time. And I subscribe to like 3 different AI tools. So I ask the questions that I am supposed to know about my own topic, and I ask those questions to AI chatbots basically. But then when it comes to using tools and implementing methodologies, it's actually terrible at doing it. And I think that's one of the reasons it's super bad at replacing us at this point. So we'll see how it goes. But so far, what's also really important in terms of research is how to implement those tools when those are needed, either experimentally or numerically. Or if you have to model something, you have to come up with proper ideas to eventually validate those ideas. And if it's hard to validate those ideas, probably it's not the best idea. But one of the things I was concerned with when I was first preparing this lecture was that probably you've noticed it, but when we go to our first material, you can see how detailed the lecture material is. Back when I was in bachelor and when I was taking SolidWorks class, the lecture was extremely unfriendly. The TA would just go through everything super quick, and then we would try to catch up the entire time, just trying to wandering our way. But you can see how detailed this material is, and it literally tells you like what to click. So I hope this was very helpful because it's also my personal experience, but also I've seen a lot of friends struggling with implementing their methodologies. And when you first get into graduate school, you come with this generic idea of like, I want to come up with like good research ideas, and I want to implement it, and now I'm going to write good papers, probably become a better researcher. But I've seen a lot of friends struggling with how to implement those ideas in detail, and especially these problems of when we say devil's in the detail, it's when it comes to implement those ideas, what to literally click and what models that we have to actually use. Those detailed arguments are always complicated, so I've seen a lot of friends struggling, so I wanted to give basic ideas of how it works, how it should work, and then if you have any hopefully potential collaboration opportunities with me, probably I'll help you in these levels as well. So yeah, I think the comment I would make is I wouldn't take this too long, but the comment I wanted to make was when you first come into graduate school, and I think this is a very useful thing to know, is that you don't really have an idea of how to implement a project, right? So your seniors and professors will give you to work on, to tell you to, they will tell you to work on these projects, but you don't really know how to work on those projects. So you have to come up with the fundamental levels of the bottom line levels of doing the most basic stuffs, and then you're gonna struggle with them. So, but I think with the proper guide, you can go through all the processes, and as you get more familiar with the material, probably you've spent like 3-4 years in the office, and then you're pretty knowledgeable in one domain, and you probably have ownership in that domain as well. But you've invested so much in learning that specific thing that once you're too familiar with it, you get to fear stepping into a new topic and new tools. But what I wanted to basically show you and demonstrate is that with proper guidance, probably you can learn new things. And even if you feel like you're in this, you met with this dead end that you can't really push through the point without learning new stuffs. With proper learning tutorials and guideline and materials, you can divert into a new direction and learn new stuff. So probably I'm not the best lecturer. I can guarantee that, because I also take classes about Onshape, and then I was try to like streamline that to you. So I hope I didn't stutter too much and muddle up like important points, but at least I was learning this material through my bachelor, and been 3 years since I started lecturing, and I hope everyone sort of gets some more encouragement in your own ability to learn new stuff. And for the next lecture series, probably you'll get to learn other tools related to other topics, because you won't use this one tool for every different topic, right? So we're gonna learn new things, and always I hope you can realize the capability that you have, and yeah, eventually if you have any struggles, you can ask people around you, and then they will hopefully guide you through learning new knowledge and techniques. So I want to bring this lecture into an end, and hope you enjoyed it. And I'll not hold you back during the lunchtime, but if you have questions about the lecture materials or the team project, please ask me. And goodbye.